Hey everyone, welcome to The Explainer. Today, we're going to try and crack the code on one of the most complex and fascinating topics out there, what general intelligence truly is. All right, so here's our roadmap. We're going to kick things off by defining general intelligence. Then we'll break down the 4 key operations that make it work. After that, we'll dive into the biology behind it, see how it's different in high IQ brains, and finally, we'll look at what all this means for building an AGI and, what the ultimate purpose of intelligence might even be. Okay, first things first, let's tackle the big question that really frames this whole conversation.
We throw this term around constantly, talking about people, animals, and especially AI. But what are we really talking about? What's the actual nitty-gritty definition behind this powerful idea?
So here's how the source material breaks it down. It's this incredible dynamic ability to build and tweak concepts in your working memory, right in the moment, to solve problems you've literally never seen before. It's all about mental flexibility. Or, to put it another way, think of it like an all-purpose problem-solving engine. It's kind of like this master algorithm that's always running in the background, ready to be aimed at whatever new curveball life decides to throw at you. So, if it's an engine, how does it actually work? Let's pop the hood and take a look at the 4 core operations that really make it run. The whole thing basically runs in a constant 4-step loop. First up is segmentation, where your brain just breaks a really complex problem down into smaller, manageable chunks. Next, you've got selective attention, where you zoom in and focus only on the parts that actually matter. Then comes binding, which is where you start connecting those pieces, figuring out new cause and effect relationships. And finally, there's integration, where you weave all those connections together into a single coherent solution. And this loop, it's happening all the time. Okay, so we've got the how, but what about the where? Where does all this happen? Let's zoom in even further, right down to the neural level, and see where the real magic is. The source uses this absolutely incredible metaphor to describe what's going on biologically. Intelligence isn't some rigid, predictable machine. Nope. It's more like a creative, dynamic dance that's happening right on the edge of chaos. And what does that dance really mean? Well, it's this perfect sweet spot, this beautiful balance between stable order and total randomness. It's the place where your brain can take old established patterns and just recombine them in completely new ways. It's almost like evolution, but for thoughts, using variation and mutation to let brand new intuitive ideas win out from all the competition. Okay, but is this dance the same for everyone? Well, not quite. The source material points to some really fascinating differences in how brains with higher general intelligence seem to work. And it all boils down to one word: efficiency. And this is where it gets really interesting. It seems that people with higher general intelligence invest their mental energy differently. They spend way more energy up front in the planning stage of a problem. And because of that, they actually end up spending less energy when it's time to execute the solution. It's the classic measure twice, cut once, but for your thoughts. And you can actually see this efficiency in action in the brain. We're talking about a smoother, less clunky switch between different brain networks. A much better ability to tap into its stored knowledge, its world model. We see more precise control over focus, and a stronger, faster ability to update what's in its working memory. It really is a finely tuned machine. So let's zoom back out for a second. If we get these principles, if we understand how this works, can we actually use them to build an artificial general intelligence, an AGI? Well, the source lays out a pretty detailed blueprint. First up, and this is a big one, it has to learn and adapt constantly. An AGI can't be static. It needs to be able to handle complex, ever-changing environments, interact with other AIs or people, build different kinds of memories, update its knowledge with new experiences, and combine all those past experiences to create new insights. That's a process called cognitive synergy. But learning is only half the battle, right? An AGI also has to be able to reason about the future. That means building and constantly refining its own internal model of the world, imagining and predicting what might happen next, and maintaining a consistent set of beliefs. And here's the kicker: it has to have a model of itself, a kind of self-awareness or metacognition. And that leads us to maybe the biggest question of all. What is the ultimate purpose of this whole incredibly complex process? What is intelligence actually for? According to the source, intelligence isn't just trying to solve a puzzle or pass a test. It's striving for something way more profound. It's almost like intelligence itself has aspirations, long-term goals it's trying to achieve. And these aspirations, They're all about growth, freedom, and efficiency. Intelligence actively seeks out surprising new knowledge so it can grow. It acts in ways that keep its future options open. It wants to hit its long-term goals efficiently, to connect ideas across totally different fields, and it even seems to experience a kind of joy when it gets to reuse old knowledge in a cool, new way. So we're left with this final, really provocative thought. If this whole thing, the 4 steps, the dance on the edge of chaos, this drive-free efficiency, if it's all basically one giant evolutionary algorithm, what's the ultimate problem it's trying to solve? That's definitely something to think about.